Okay, so the next, we would like to summarize the one sample t-test for general case. So at first, some notation. So if capital T is a t-random variable with degrees of freedom n, we define the t sub alpha parenthesis n. Alpha is some probability between 0 and 1. The constant satisfying this. So that means if we have area alpha in T distribution, so here is 1 minus alpha, and then we define this as T alpha of n. So this is the density of Tn. So this is the definition of T alpha n. And we define this for normal distribution also, and we write this as Z alpha. And you can see that this notation is useful to describe the t-test in general. So for example, what is the T sub 0.975 of 6? So that is quantile point for T distribution with df6. Okay, so maybe capital T maybe. Okay, so T distribution. This should be symmetric. It's hard. Okay, so this is T distribution with df6. Then 0.975, so probably around here. This area is 0.975 and this is 0.025. And then this point is T sub 0.975 of 6. And in our language, we can use the Qt function to calculate this. And remember that this was 2.4469 in the previous video. And we can see the same thing for 0.025. So think about this is the 0.025. Then this is T sub 0.025, 6. So we can use this for testing. So these are exactly the threshold for t-test for df6 and the two-sided and 5% significance level. Okay, but anyway, so we define this, and for normal distribution, we can do the same thing. So remember that normal distribution, if you have taken stat 20 to 10 or 10-20 or whatever as a course, center 95% coverage. Okay, so suppose this is 0.025, 0.95, and 0.025, then this was 1.69 and 1.96 and negative 1.96. So, so these are Z sub 0.025 and Z sub 0.975. So you can see these values are actually smaller than the T case. So T distribution generally has large quantile for, you know, if these values are reasonably close to 0 or 1. Okay, so using this notation that we describe the test procedure for two-sided test, one sample test. And the first case, we have null hypothesis of mu is equal to mu naught. Mu naught is just a constant. In the previous example, that was 79,500. And alternative hypothesis is mu, mass PhD's average salary, is not equal to 79,500. We don't say it's larger or smaller. We don't say that, but just different. So that is the so-called two-sided test because H1 is the both sides of H0. mu is either larger than or smaller than 79,500. Okay. And in this case, that we reject null hypothesis if and only if the capital T is larger than this T sub 1 minus alpha over 2. So that is, so T statistic and T sub 1 minus alpha over 2. Alpha is usually a small number. It's called significance level. So if this is 0.05, this part is 0.975. So that means, as we've seen in the previous slide, alpha over 2. So T sub actually 1 minus alpha over 2 and a negative. So if T falls in this area or this area, we reject H naught. So center coverage is 1 minus alpha. So this is the procedure for two-sided test. So two-sided test means, again, the H1 is both sides of H naught. So also sometimes we do one-sided test. So H naught is the same, but H1 is mu is smaller than mu naught, or in some case, H1 is mu is larger than mu naught. And in this case, okay, so in this, in this case, so reject H naught if and only if capital T is smaller than this value. So this is just the left tail part. So if we have T distribution like this, then this is T alpha. Okay, so alpha is small value. So this area is alpha. And T sub alpha n minus 1. So if T falls in this range around here, then we reject null hypothesis. Because alternative is mu is smaller than mu naught. Right? So if x bar minus mu naught, so if H naught is H1 is true, then this should be some small value. Right? So even we normalize it, that should be small value under H1. So that means for smaller t, we reject H naught to support. Yeah, actually for DF6, actually this threshold is equal to negative 1.943. So actually it's a little bit closer to 0. Because the last time that we just set the threshold so that the lower tail is alpha over 2. So 1/2 times alpha. And the upper tail is also times alpha. But here only we reject when T is smaller than some specific value. So this area gets a little larger, actually twice as large. So the threshold gets a little closer to 0. And the other way is the same. So if H1 is this, reject if capital T is large enough. So if H1 is true, H1 here is true, then x bar minus mu naught is large value. So then if this value is large, we should reject H naught to support H1. So rejection region was there. So if we write T distribution, rejection region is upper right tail. So we take, then here is the rejection region, the threshold for. Yeah, so this is the general theory. And the next we discuss, see how to implement this t-test in our language. And actually we have mentioned a little bit in chapter 1, but we have a t-dot test function. So income is the vector of 7 mass PhD salaries. PhD salary. Oh. And this is null hypothesis. Then it implements the one sample t-test. And we get the t-value, degrees of freedom, and we will explain this p-value later. But actually, we can see that the alternative is this one. And yeah, actually, we cannot really see from this, but we do not reject null hypothesis if this one is larger than 0.05, the significance level. So if this p-value, so-called p-value, we will explain it later. If this is larger than significance level, then H0 is not rejected. So since significance level is somewhat subjective, so the p-value, if we have this so-called p-value, we can always compare our significance level with this value to conclude that whether H0 is rejected.